So today I will be showing you MDTools 900 on SolidWorks for this time. Since we started this journey of webinars in October, I had never used MDTools on SolidWorks. So yesterday we released the 975 beta. So I want to show you the changes compared to the older version. For Inventor users that are attending today, there is no major difference in terms of user experience between Inventor and SolidWorks. MDTools is a plugin specifically designed for making hydraulic manifolds. So the commands that you find in SolidWorks are basically the same that you find also in Inventor. And we are almost not using any specific command of SolidWorks or Inventor when designing a block. We just use the MDTools specific command. Our exercise today will be start from a diagram that I have already made with the HyDraw. It's a mobile application. It's a smaller regenerative circuit that I have already made. So let me open it. So the number of valves is not huge, but still it is a good exercise. So for those designing mobile manifolds, normally really with cartridge valves, with many cartridge valves, with lot of connection, things can get very, very complicated when you start building the manifold. So our manifold today is made of 5 cartridge valves. I also added an orifice plug, so we'll see how to use orifice plugs in our design. Each of these items on the bottom right part, you can see that I have already the 3D model in SolidWorks format. So at the end of the exercise, I'll expect to have an automatic assembly of my block. I don't enter into much details with HyDraw. I will just show you 2 commands, which are basically the netlist. Netlist is finding the connections in our schematic, and I renamed the connection into C1, C2, net4, net3, tank, and so on. So netlist is helping us with understanding if we made properly the connection in our diagram. And then I use the MDTools command to export the information of the diagram to MDTools. The same interface works seamlessly in Inventor. Simply there you will need to use an IPT file instead of SolidWorks files. So now I'm exporting this file into my this folder. And let us call it MDTools webinar 03. We just keep the diagram on the left part because I will need just to place the first component in my design, and then I will simply ignore the diagram during the design process. So let me bring this here. And let me clean up a bit of the interface. So we start always with our block. And let me take a 150 by 150 by 150, a cube. Now, instead of looking for the cavities that we have in MDTools library, so basically when we normally design, we can approach to the library by looking into each folder. Let's say I need a sun hydraulics valve, T10A, and the component ID is maybe item 5 in the block. We can insert the cavity into our design. And if you insert the cavity without net information, no color will be applied to the port A and port 1 and 2. But for instance, we need another cavity 6 that is connecting maybe a P line to a tank line, and we place it. Now the same cavity will have colors. Instead of designing manually, like if we had the diagram on paper, we are loading the diagram, the HyDraw diagram that I have made on the other software. So we don't load the DWG file, we just load the XML file that has been generated by HyDraw. And the XML file is called MDTools webinar 03. Let me open it. These two cartridge cavities that I put in the block do not really match anything in the diagram, although you can see that item 5 and 6 are now grayed out. So when you import a schematic into an MDTools project, this dialog will gray out a cavity that are already with the same item ID in the block. That does not mean that the block is correct, but if we run a command that, let me enlarge a bit. If we run this command that is called check against a schematic, we can start, and now MDTools will verify if we are missing cavities, and we miss a lot of items compared to the diagram. And but as you can see, we have item 5 and item 6 with round cavities. So our diagram is different, has different information for those cavities. So basically, I don't need those two cavities in the block. So let me get rid of them. So I delete them, these two cavities, and I will start my design from scratch. I want to initially define a bit of placement for my components. So if we look at our diagram, on the left, I have this will be coming from our directional control valve, V1 and V2. So maybe we put those ports on this side of the block. C1 and C2 we will put behind. And most likely our valves will go on top, or maybe on the front and back face, depends on how this block is coming through. So we will take just our cavity V1 with a double click, and we touch the face, and let's leave it where it is for the moment. We take our cavity V2 and we place it here without paying too much attention. Then we rotate our block, and I just take my C1 and C2. For those that are already using MDTools on SolidWorks, the big difference compared to the previous version is that now, if you go to the SolidWorks browser, you will see different icons for the cavities. So we are using Advanced Hole feature instead of the revolved cut. This is having a big improvement in performance compared to the previous version of MDTools. In fact, I am designing directly in feature mode today. I will not use the virtual mode. Although you can always, if you want to speed up the design, you can switch to virtual mode as well. The same virtual and feature mode are available as well in Inventor. So let's go on with our design, and let me start placing some components. So I place the directional control valve on top. So when you place a cavity, as you can see, we have the origin of the face, and we have the initial position of the cavity. I strongly recommend when you design to specify good position for the cavity, let's say 50, 100. Then of course you will be able to move, but the first cavity is better really to place in a good position, so that later all the other cavities will just connect well. We can see colors, and we understand that there may be some connection available. So the light blue color, this one will need to go here. So let's make a connection. Connect cavity V2 with this port in the center, and we move it down. As you see, by using this technique of placing the first cavity at 100 millimeter on the X direction, and now we already have the 100 millimeter for the V2. So now what we control is only the vertical position. Let's make it 80 millimeters, and we click OK. So now MDTools is placing the cavity, is making the connection, and we clean up our sketch. Let's place other components. So I take the component 3.2 and I place it on top here. And I want to position from the other cavity. So I can use a reference to this cavity. and I want same X position and maybe 45 millimeters from the other cavity. And I click OK. Again, we can do a construction port. So in my design, in every design, you can decide which construction port you want to use. So if you go in the MDTools options, under construction ports, you can see that now I'm using BSP plugs, but by clicking here, you could add a different library of construction plugs. I'll stay with BSP. Maybe later I will use an expander plug to show you. It depends on how the design is going. I need to connect the tank lines here, so I will do a construction port between this cavity, and let's say that I need just a 1x4 BSP port, and I put it down here. Again, I can define the position 50 and let's say 80 millimeters, and that is good. I can make a connection. And if you see the color disappearing, this is a small bug I found in the beta. You just edit and click OK. This will be fixed then in the final release of the software. Now we can see that red. So those cavities must be connected together. We just touch this cavity. We say connect to the red cavity. Automatically, the cavity will jump to the center of the connection and change in the diameter. And I just click OK. Let's start placing some additional components. So we take, there was a pilot operated check valve normally open. Let us place it here and we see if it's a good position or not. Yes, so let us remove a bit of material from this face. So we touch the face and we make it, we can uncheck the snap to bar, and we can position this maybe at 85 millimeters. So now in this case, MDTools will just remove some material from the right face and do again the connect. While I need more material on the back face, let's make it 120 millimeters. Let me move this cavity slightly down. And you can drag the position of the cavity, or you can specify a X and Y dimension, 50, 45 from that edge. I see that I have some net with the same color, so let us verify. If you want, you can change color for the net. So most unlikely, these two should not the same color. So under nets, you can see what is actually present in our design. So there are several nets. Of course, we have a view by cavity. Those are all the cavities that we have in a block. Or under nets, we can change color. So let me change color for this net here, and I make yellow. So this will change all the cavities belonging to that net. And as you can see, this is the pilot of the normally open pilot to close a check valve. So I can connect this with this one by using the color, and maybe I put 50 millimeters on the X direction. And also I want to connect now my C1 port. Let me save my block. Let me put it on the webinar. Let me call it webinar block. And now I can connect also the other cavity here and make a connection. Now we go on with our design. We go back to the HyDraw schematic and start placing, there is a FC8S2 cavity, which we place it on top. Ideally, we try to put all the cavities on top, and then we'll see if this is working. We see blue connection, so we can connect directly this one here and maybe position on this direction. Let's make it 35 110 millimeters. This is start looking good. Maybe we can remove material from the bottom face. We make it 100 millimeter. And we can save. When the engraving is not in the face, you can go to the engraving text, edit. You can take the V2. In this case, you can edit it, and you can specify a new location directly touching the face. Let me also move the V1 and I put it here. Let's go back by net. So a different approach, instead of just taking the cavities and place them and understand how they are connected by looking at the colors, we can really expand the net and see which cavities are belonging to each net. So for instance, here we see that the net B with this dark green, we can just insert the cavity and place it here, and we could make maybe a connection, but I don't really like this position. Let me make it here, or change face and put on the top face. This probably looks better as a solution. Later we will be able again to change face if we need. Now we can see that this port maybe could go on a bit on this direction. It is okay. We want to connect the same color, so we create a construction plug on this port. Continue, and we place on this face, and we click OK. And now we can connect again, export 1x4, and we position here. We always can take a reference from other cavities. So now, as you see, by using reference and touching another cavity, the origin is dynamically changing. So now this is the origin. So we want to make the Y direction to 0. So we go to the Y direction and make it 0. And also, since we're here, let's make a 30 millimeter on the X direction. Now we can use the align command to align this cavity with this one, so that they get the same 30 millimeter X distance. We can manually reduce this connection, but there is a command in MDTools that is called check band that automatically verify all the intersections, and we can run this check. And as you can see, it is finding current depth and recommended depth. We can trust and click update all. This command will make all the intersection now smoother. And now, as you see, automatically MDTools made my connection better. We need to make again some connection. This is going to be a tank line like the other one, so we need to bring the connection down to the light blue. So let's make a plug here, and we position on this position here, and we click OK. Then we make another construction plug on this port, and we put it here. And we can use a command called stretch to make a cavity go to from another up to another cavity. This is not really a good connection. They are not, the difference in diameter is very large. So in this case, a technique could be make this drill larger, let's say 8.5 millimeter up to 50, or maybe we just make it up to 40 millimeters, that's okay. And then we can add a drill to the same cavity. So we make different steps of diameter. We need a 6 millimeter diameter, and that will go up to 85, so that we make the connection in the same position. And when you do that, MDTools will ask you to add an instruction that will go in the machining drawing. So we leave this instruction, we put it on top, or you can select where to put the instruction, and we'll see in the machining drawing at the end. So I click OK, and now, as you can see, my drill has changed the shape. Now it has 2 different diameters. We go on, and there is a orifice plug here, which we will need to connect. And it is connected on port 2. So the orifice plug is also on the yellow net. So we need to, the orifice plug is connecting basically this dark green with yellow. So let us create a construction plug here. Let me take a G, 1/8 is fine, but I want 8.5 millimeters diameter. And I want to put it here. And let us position maybe 136, 50 millimeter. We can stretch this drill slightly. Let's make it 40 millimeters, so going outside the drill. And now we can add our orifice plug to this drill. And now MDTools is adding the orifice plug inside our drill and is adding also the engraving, item 2. We can stretch this drill and go up to the yellow connection. Let's make it 65 millimeters. And now we have made also the connection. Again, this color, to refresh this color, we just add it and click OK. And now we'll see that the color is updated. Anytime during the design, we can verify if we are missing something for the connection. So we can do the connection check that will give us a picture of what is happening here. Basically, we have broken nets. So the tank line is broken, and the tank line is this light blue. Let me change a bit of the color so that it will be easier to understand. C1 is also broken, and also C2 is broken. If we want, we can also compare the block with our diagram. So if we do the check against schematic and we run start, now we see that we miss only 2 cavities, the test point and the pressure switch. It will be easier to place them only 2 ports. We will find a place. So now let's first focus on doing all the connections that are needed. In order to help visualizing the connection needed, let me go back to the net. And I want to change the color to the net C2. Let me change color and take an orange. So now this will be easier to identify. So I need to connect those cavities. And basically, a smarter idea would be just to change phase, if doable, of course, depending on the constraint on the design. But we could say we put this cavity here, we connect directly to that plug, and later we will remove the back construction plug. Let's select position 20, 55. That is fine. So any cavity that you have placed, you can change phase and position. We can remove the other plug. And now we can just simply make a construction plug here. So we add a construction plug on port 2 up to the other cavity. 1/4 is the size that MDTools has selected for us. We can make a connection tangent on the other side, and we can click OK. Normally, when a cavity is very close to the edge, there is a problem that there may be some overlapping problem between threads. So we will need to, let's say, in this case, I want to change the depth of the spot face. Let's make it 1 millimeter, as less as possible. But still, we see that our geometry is not that good. So we will need maybe to move slightly this cavity again. On this direction, and that is a possibility. Or On the other way could be really apply a very different approach. So let me show you, because really when we start placing cavities, the advantage of MDTools is how quickly you can apply a change to a design. And so here the designer eyes is what really help in finding a better solution in the design. So now I saw that I could move all these cavities down, and let me move them down by all these increments. I want to move my cavity in between here. I forgot to select, so I align this cavity with this one. I can move this port on the right. I can stretch my drill. And now, as you can see, by using this technique, really this can be also flushed. So I can have the head of the plug really completely flush. We can refresh the color. My port can be moved up to make the connection. Let me make it 50 millimeter on the X. I can also stretch this drill to make the connection there, 100 millimeters. And now, as you can see, I am here with this drill and I have the dark green. So of course, this drill is not in a good position, but it is very large, so we can make it smaller. And basically, we can see that we have room to make the connection in between. So we can do a move multiple. We can take all these cavities and move them to the right. Let's make it 2 millimeters, 10 millimeters to the right. Now we can make a construction plug on port 1 and here, and we can take 1x4 is okay, and we put on the top face. There will be possibly a intersection between spot face. So let's move the green side. And we have made our connection. So our blocks start having a better shape. We need to take the tank line down, and then I think we are almost done. But now doing this technique, we have really gained a lot of volume, so we can make it maybe 125. So 25 millimeters less in manifold length. Looks good. Let's do the connection of the tank line. Let me insert the tank line, and we can go maybe here in the center, and we can move it slightly offset here. And we can copy this cavity, position here, connect, and connect also with this one. Let me recolor the block. So this command will recolor everything. And let's verify if we have made all the connections. So with the connection check, we can verify if we are missing connection. So there is a broken net. Again, the dark blue is not connected. So let's do that as well. So we can stretch this connection and make it down here, 60 millimeter. We want to make also a construction port here, and we make it tangent on the other side. We can move multiple. We move all these cavities, and we will move on the Z direction in order to keep distance from the other blue connection. We also need to connect this port tangent on the other side. We have overlapping spot face, so we can move this cavity slightly to the left. And we can keep the connection. Otherwise, we could add also an offset hole, but this is fine for today exercise. So now we can go with the connection. Here, and now we have room for a connection on top here. Let's say 1x4 here. 1x4 is too big. We will replace the cavity with a 1x8. So we can do a replace this cavity, and we can go to the BSP plug 1x8 drill depth. So we keep the same drill depth. Now we have made that connection. We have the challenge to take also this blue connection here, and let's try to make an inclined connection if doable. Let me see what we can do. Move. Let me move this cavity down a bit. Also this one, it's better to move it down. That is okay. Yes. Let's see, just to show you a bit of functionalities. So I want to make an inclined connection from this side that goes directly to the blue, passing on top of the green connection. So let me make a construction port 1x8 here, and I put it here. I'll move it slightly up. And now I'll make an inclined connection from here up to here with inclination. There will be an intersection with the other cavity, but now I'll find a different solution. So this is okay. I will move this cavity down. Yes, that's good. So let me move this here and change face. This one on the opposite side, keeping the same position as previous, connecting to this cavity. I really need to move everything down, so I will need to move this cavity down. And all the ports down, and my cavity down. And now I think this can work, and I can move this cavity just down a bit. Let's verify if now the connections are made. We do again the connection check. We can start. And there are still broken nets, but yes, those are the blue connection, also the yellow connection. We do very quickly. Now we create a construction plug and position it here. And we stretch our block up to here. And also this one will go slightly deeper, 70 millimeter diameter. Let's do again our connection check. So yes, now we have just a few minor issues. We'll see here. We have dead area with the dead area intersection. So here there is a potential collision So we will just change the depth for the spot face. Then we have also this drill that is touching the thread. That's not really a big deal, and the same on the other side. So all the problems now are concentrated on this position here. So we find a better solution. So we change the depth for the spot face. We also slightly change the depth for this spot face. We make it 3 millimeters, so that we can move slightly this cavity by 2 steps to the right. And now probably all the connection issues will be disappeared. So now, as you can see, MDTools is verifying that I have made all the connection properly. There may be quality problem in the connection. So if I check the quality of connections, now MDTools is verifying also if I made a proper connection. So for instance, there are some quality problems, which I saw one, which is this one. So as you can see, this drill is very short. Let me change the color. This drill is very short, so we can make it better. So let me make this drill slightly longer. Or you could use the check bend command that we have used before. Last operation I made before going to the wall thickness check is I had some mounting holes. So mounting holes, I had M8 4 pieces down here. I normally add mounting holes at the end, but sometimes it's better to place initially so that you understand if the cavities are well balanced, are well positioned. This cavity is too long, so sorry. I need to shorten it. Maybe 80 millimeters should be fine. Let us also verify the wall thickness. So with the wall thickness check, we can verify for 4 millimeters all our block. And basically it is finding only in this case issues in the same net, which is basically not a major problem. So like in this case, it is saying that between these 2 cavities, let me highlight it. This cavity and here at the end there is 1.5 millimeters, but they are connected from the sun cavity. And the same problem is probably here. Yes, between these 2 inclined cavities here, 1 and 2, but they are connected. So basically, when you find clearance in the same net, normally give a look, but that's not a major problem. While here there is a clearance between the spot face, which is here. And let me highlight it. So it's here. But again, this is not a major because the O-ring will be here for the cartridge, and the sealing will be on the spot face for the plug. So in terms of wall thickness check, I find this block good enough. So I move forward with the machining drawing. Before doing the machining drawing, I keep just the assembly drawing at the end. It will be only automatic assembly. Before doing the machining drawing, I'll just change the position to the engraving because I see some engraving not in a good position. So let me edit and specify a new location. Of course, you can go through each engraving and move. V1 is not good. Edit, and we position here. And 3.1 is not in a position. Edit, and we change location. If you want, you can also engrave all the cosmetic engravings. So you can go to Edit, Edit All, and specify a depth of cut, let's say 0.2 millimeters. So now MDTools will put all the engravings in the block. Let me save my block. Well, this plug is not needed actually. Delete. the connection now is able. I am able to make the connection this way. That could be an interesting MDTools command. Find cavities, construction plugs that are not connected to anything. Okay, we keep for enhancement. Okay, now I'm ready. I will do automatic machining drawing, and then I'll switch to the assembly. So to make a machining drawing, we have a command directly from the part environment. This is a small mobile block, so I will use the machining callout, no drill chart. So I will run this command, machining drawing. There are some options. I will quickly go through what are my preferences here. So I have a template. So my template is an A1 size. Then I will put the dimensions, the machining callout, nothing else really. I don't need anything else for this drawing. I have the dimensions, so I can specify the origin. So it will be bottom left, but really you can change the origins as you want. And there are some configurations for the machining callout. There are a lot of options available here. Really, it's up to find a good balance between what you want to have in the machining drawing. When you are set with the configuration, really what you can do is just create a drawing. And now MDTools will make the machining drawing for you. So it will put the 6 views of the block. Now it will start putting the dimensions. We improved a lot the speed for dimension creation in this version of MDTools. It will for sure, of course, use your standard that you have in SolidWorks or Inventor if you are using the Inventor version. So now MDTools is looking for each views and is adding the dimensions for the cavities.
If there's any questions you have while Carlo's finishing up, this would be a good time to post. Thank you.
Now it is placing the machining callout. This is the only manual work that you will need to do for your machining drawing, which is basically just positioning the machining information for the cavities in order not to overlap. So let me just show you an example. For the drill chart, it is even easier because the drill chart, when you have a position, then you don't need anything. So here, if you use this kind of machining drawing, then what you need to do is just find a good place for those information. So as you can see, we have a drill and information, BSP plug with the pilot drill and the spot face information. So here what we need to do is just paying attention to the cosmetic of our drawing. And that's basically the machining drawing. Of course, if you make a change in the part, then MDTools will ask you to update the machining drawing if you need. Let me save my webinar block drawing. And now the last part, although we have reached the limit, but let's do quickly, it will not take long. I make the assembly. And since I had the information from HyDraw with all the 3D model, we can do the automatic assembly of the block. So we take our file, the webinar block. Now MDTools is listing all the 3D model that it is going to place on each cavity. So here we just need to click assemble, and now you will see MDTools opening all the 3D models. So you will see all the files that are involved in this assembly being loaded a couple of times, and then the assembly will be built at the end of this process. Of course, in order to be able to assemble these components automatically with MDTools, you must follow the rules that I have described in one of the previous webinars for the assembly rules. By the way, all the assembly can be made also with standard SolidWorks or inventor commands by what you normally do in when creating assemblies without the full automation that is available with MDTools. In this phase, you will see all the parts really showing up several times, but at the end, we will have our 3D model assembled properly.